Hey guys, it's Mr. E here. In this video, we are going to look at the density pre-lab. So this is going to be our lab skills, measurement, talking about density. I'm going to go over several of the questions that you will see in today's assignment. Okay, so make sure you're paying attention, taking notes, or when you do the assignment, you can come back to the video. I'm also going to give you guys this PowerPoint. So today is day 15. We are starting Unit 2, which is on properties of matter and change. So we're actually getting into some chemistry. We're going to talk about some lab skills, about accuracy and precision, percent error, things like that. We're doing the density pre-lab, which means that our lab is going to be on density, and we're going to be doing that lab later this week. What I'm going to do is I'm going to make a video of myself demonstrating the lab, and then you guys will kind of watch it and then work up some of the problems and try to figure out a couple things. Okay, and I'll talk about the lab a little bit here too. So today is Monday, September 21st, A day, or if you're watching on Tuesday the 22nd, then it's a B day. So I make the same video for the 2 days of class because we do the same thing. Okay, so here is our calendar. We are in the last 2 weeks of the grading period. It's hard to believe, but we are getting close to a quarter done with the school year, so 1/4 of the school year. That's blowing my mind because it seems like we just started, but virtual was kind of fun. First 3 weeks of school, 3 or 4 weeks, however long it was, and then ever since we started face to face, it's been pretty good. I don't know how you guys are doing, but I mean, I'm as a teacher, I feel pretty good. I think most of my students are learning. I had some really good grades on my last test, even though it was super long. I do apologize for that. The next one will be shorter. So as you can see, Monday and Tuesday is day 15. And actually, I posted this on our website. So let me show you that. So I posted this on Canvas. So if I go to Canvas here, I go to chemistry. This is what our homepage will look like. So it's got live virtual class. Of course, you guys know that. And then it's got a link of assignments that will be on the progress report. So if you need to look at old stuff, that's where it's at. Okay. And then here's our calendar. And then, of course, here's the same thing. Actually, I need to take off this Google phone because it's gone. But there's my email and all that. There's me rocking out. Oh, yeah. Then we got, so that's day 15. We're going to do the density pre-lab, and then we're going to start Unit 2 just a little bit. And then on Wednesday and Thursday, we will be spending more time on Unit 2, going over notes and stuff. And then I'm going to assign the Unit 2 classwork. And I call it classwork number 1. It'll be our first one. On Friday, my A day will be doing the density lab. And then since I see A day again on Monday, next Monday, we will be finishing up Unit 2 and or part of Unit 2, about half. And then I want to do a quiz over the stuff that we talked about this week. So next Monday, we're looking at a quiz over Unit 2, and it shouldn't be too bad, but it is an assessment to see how you guys are doing, and if I need to go back and reteach things, then we will, especially virtually, because you guys get out of this class what you put into it. So if you're watching and paying attention during class, then you'll be learning some stuff. I'm doing my best to try to teach you what I can. B day, we'll be doing the density lab. Okay, and then the 30th will be kind of a review of stuff that we've covered. So I'll probably be going over that quiz and reviewing Unit 2, and then we'll have a makeup day. Since for A day, this will be the last day of the quarter, and so I want to have a day there to get people passing. Okay, I don't want to be trying to test that day or do something crazy that day. I want to be able to get people caught up if they need to. Thursday, we'll do the Chapter 2 quiz for B day classes and finish up Unit 2. And then the Friday at the end of the quarter will be a review and a makeup day. Okay. And then the next week is intersession. And I hope you guys are doing intersession so that you can recover credits or, but please just look at the options and see what they have and try to sign up for something. It's only half a day and should be good. Let's see. Okay, so that's it. All right, learning objectives. So students will be able to determine the volume of an object by displacement. And you guys should already kind of know this, okay? If I take a cell phone and I put a cell phone in a pot of water, I'm going to watch as this happens, the water level will rise. That's displacement. The water level will rise, and I can look and see how much volume, how much water rose, and I know that's equal to my phone, the amount of volume of my phone. So that's displacement. All right. I don't recommend doing this, of course. Although I think my phone is waterproof supposedly, but I wouldn't test it. Calculate the density of an object. Okay, so we'll talk about density a lot. So we should be able to calculate the density for an object. Predict whether an object will sink or float in a liquid given the relative densities of both. So if I tell you the density of an object is X, and I tell you here's water, if I put that object in the water, is it going to float or is it going to sink? Or is, is it going to float or sink? And then we're going to understand the difference between physical and chemical properties. And we're not going to do that in this video. That will be in the other video. So we got 2 videos for today. Hopefully they won't be too long. I'm going to try to make them kind of short. Density pre-lab. So students will complete the pre-lab during class today. This is what I'm grading for credit for today. The pre-lab involves 3 tasks. So there's a reading that we need to read. Okay, so please read that. And if I click on it, it opens up I think this is a PDF, and you should be able to open this. And what I need you guys to do is to read it. It's 3 pages, but it's pretty easy read. It's not bad. And I'm going to go through it in this video. Okay. And then, so watch this video, and then we're going to complete the pre-lab assignment. And let me go ahead and show you what that looks like, just so you guys know everything that we're doing. So here's the density pre-lab. Email address, first and last name. These 2 questions, just put yes. And then answer the questions. Like I said, some of these questions we're going to go over. Okay, this is the main thing that we need to be doing today. Students are to read the pre-lab reading passage, watch this video, the density pre-lab video lesson, and then complete the pre-lab assignment during class today. Okay, if you do not get finished during class, I will kind of just have a hole in your grade for class, and then once you turn it in, then I'll put in the grade for that. All right, and if you can get it in today, I can give you 100. When finished, students will watch the intro to Unit 2 video. So at the end of class, I need you guys to watch the intro to Unit 2 video, which I'll make pretty short. It shouldn't be too bad. What did we learn from the reading? All right, density is mass divided by volume. All right, mass is grams. Volume is milliliters. Okay, so mass divided by volume. The unit for density is grams per milliliter for liquids, and grams per cubic centimeter for solids. All right, so it's grams per milliliter for a liquid because the mass of a liquid is measured in, or the mass of something is measured in grams, and then volume for liquid is milliliters. That's our go-to unit for milliliters, or for volume. So if you look at a graduated cylinder, it's got milliliters on it. And then if you do a solid, let me draw a picture. So think about a solid. Where is it? There we go. So if we draw a cube, if I'm going to find the density of a cube, right, I need volume. Remember, volume is the length, which I guess let's call that length, and that's width, and then that's height. So it's just length times width times height. Length is measured in centimeters. Height is measured in centimeters, and width is measured in centimeters. So this is centimeters times centimeters times centimeters, which is a centimeter cubed. And so it's grams for mass divided by volume, and our volume is centimeters cubed. Now 1 cubic centimeter, which is a cube like this, where each side is 1 centimeter. So the length, the width, and the height are all 1 centimeter. So think about a little cube about the big as your fingernail. Okay, that is equal to 1 milliliter of liquid volume. Okay, so that's a really important conversion there. Density is a physical property, which we will talk about in the other video. This means that when we measure density, if I were to measure the density of an object, we are not going to chemically change it. We just need to physically observe and measure it. We need to measure the mass and the volume, which in order to do that, we don't need to change it into something else. So that's what we mean by a physical property. Density is an intensive property, which we'll be talking about in another day later this week. This means that the density of an object does not depend on how much of the object that we have. For example, if you have a tiny piece of gold or a large gold block, if it's gold, it will be very dense, right? I don't know if you guys know, but this is very dense. right? Metals are usually kind of heavy, right, for the size. But it doesn't matter whether it's big or small. If I had a little piece of gold or a big piece of gold, it's still going to be surprisingly heavy for its size. So that's what we call an intensive property. Okay, so here are some answers to the from the assignment. Okay, what did we learn from the reading? You love density. So here's a cool way to remember the formula for density. We love density. So let's draw a heart. Oh, that's beautiful. Now let's draw a line there. Now let's change colors. And look, M for mass divided by volume. We love density. Isn't that cool? So if you draw a heart and draw a line through it, we love density. It's mass divided by volume. You can see the letters there. All right, so if we measure the mass of an object to be 12.5 grams and its volume is 125.4 milliliters, what is the object's density? So remember that density is mass divided by volume. So we're going to do 12.5. I take the mass right here. That's our mass. This is our volume. I'm going to take my mass. I'm going to put it in the top of that equation, right? Because that's what M is, mass. And then I'm going to divide by volume, which is down here. So that's going to be 125.4. Okay, so plug that in the calculator and see what you get. Okay. What did we learn from the reading? We already said this, but 1 cubic centimeter is equal to 1 milliliter. Okay. The standard for density is pure water. So that means water with nothing else in it. It's pure H2O, high quality H2O. The density of high quality H2O is 1 gram per milliliter. Right? So so water is defined as 1 gram per milliliter, and if something has a density less than that, so if the density is less than 1, it will it'll float. Okay, it'll stay above it, right? So if you got water and you take an object, so here's our water, you take an object, it'll stay on top if it's got a less density than water, like a stick, right? Or a block of wood or something, it'll float because it's got less density. Now, if the density is greater than water, if it's more dense than water, then it will sink. So think about taking like a piece of metal, like a screw or a nail or something, and putting that in a block of water. It's gonna be sitting on the bottom of that water. It's gonna sink. All right. Regularly shaped objects, we're gonna use this equation for volume. So like say a cube. If we have a cube and we want to know its volume, we just do length times width times height. Length times width times height, right? So length times width times height. And we get a cubic centimeter. However many cubic centimeters it is, that'll be our volume. For an irregular shaped object, the volume is found by displacement. That means that we are going to submerge the object in a graduated cylinder with a known volume. So let's take a graduated cylinder. Let's fill it up with, let's say 50. We're going to put 50 milliliters of water in there. I think I'll be doing this during the lab. I take a graduated cylinder, I fill it up with exactly 50 milliliters of water, and then I take the object, say it's a cube, or no, it can't be a cube. It needs to be something irregular. Let's take a bolt. Let's take a bolt or something. I don't know if I can draw a bolt, but it's just getting worse. So we take this weird shaped object, we put it in the 50 milliliters of water, and what's going to happen? The water level is going to rise, right? And so it's going to go up a little bit, and then we measure that volume. Let's say it's 60 milliliters. All right, so we had 50. We added the object. I put it in there, and then it goes up to 60. So what is the volume of the object? It's equal to the difference in the volume because you added it in there. And so the volume would be 10 milliliters. That would be the difference between those two volumes. Cool? Now, here's a question. If an irregular object displaces 10 milliliters when you put it in a graduated cylinder, what is the volume of an irregular object? So I put this one in here because I remember last year when I did this lab, students just did not get this question. I think they were overthinking it, but it's the same thing that I just did. I've got my graduated cylinder here. I've got, I don't know how much. Let's say this is 500 milliliters, what it looks like. Okay, I add my object in there. Now I've got my weird shaped object, whatever it is. Okay, I got my object in there. The water level goes up to 510, right? And it displaces 10 milliliters in water. That means that the water level goes up by 10 milliliters. So what has to be the volume of the object? 10 milliliters, because it moved the volume up by 10. All right. Accuracy and precision. So here are some examples of throwing darts. So imagine, let's do some names here. Let's say this is John. Whoa. So John here still looks like a 5. That's weird. Okay. John here throws darts, and I mean, they're everywhere, right? There's one there. It's not really any consistency, and it's not really hitting bullseye either, right? All right, and then let's say Ken comes in. Ken is off, right? This is not where he wants them to be. He wants them here on target. So they're not on target, but they are consistent. They're all in a small area, okay? And then down here, let's say Mary, who's the expert dart thrower, she throws all of her darts. They all go in the bullseye. Very nice. So what we want to be able to do is look at these 3 throws, John, Ken, and Mary's throws, and see who is accurate and who is precise. Okay. So let's have a look. Accuracy is how close a measured number is to the true value. Okay, so what does that mean in terms of darts? Now, you always use darts to think about this. There's my dartboard. If I'm trying to measure a number and get close to a true value, it's like throwing a dart and hitting bullseye, right? So if I hit bullseye, that means I am accurate, right? That's what accuracy means. How close are you to what you're supposed to be? All right, so if the force of gravity is measured on an instrument, it can be compared to the universally accepted value. So we know what gravity is very well. We've measured it thousands of times, hundreds of thousands of times. So we know that gravity is 9.8 meters per second. So let's say I do a lab. I measure the force of gravity in my lab. I get 9.7. Well, that's pretty close to what I should have got. And so we can compare those numbers, and if they're close, we can say it's accurate. All right? And so we can do it as like a relative difference. So we can say 9.7, 9.8, that's pretty close. So you can say that they're close, and that means that they're relatively accurate. Now, there is an equation that you can use to determine exactly how accurate it is, and that's called percent error. Okay? And so percent error is the measured minus true value divided by the true value times 100. Okay? But I don't think we'll be using this equation right now. We might see it later, but that's how you would calculate it. And then you would be able to say exactly how accurate are you. Well, you had 10% error. You had 5% error. You had 1% error, right? Whatever. Exactly how off it was. So accuracy is how close to bullseye you were. So let's go back to our pictures. Ooh, I still got my drawings on here. So who was accurate? John did not hit bullseye. He was not accurate. He had too much to drink. Not accurate. Okay. He needs to practice. Now, Ken was not accurate. He did not hit bullseye. Now, Mary, she hit bullseye over and over and over again. Let's say that this whole circle here is bullseye, and they all went in bullseye. That means that's very accurate. The dart went exactly where it was supposed to go. Okay, so that's accuracy. Did you hit bullseye or not? So I want you guys to understand what it means conceptually with darts, but I also want you to understand what accuracy means by the numbers. If I measured 9.7 and I'm supposed to get 9.8, if those are very close, then I was accurate. So you need to be able to recognize that with numbers, okay, if they're close. All right, now precision is how close measured numbers come to each other. All right, so let's say again, if I'm measuring the force of gravity, I'm doing it in the lab. Here are my measurements. I get 9.8, and then 9.7, and then 9.9. Right? You want to do it several times and see if your measurements are consistent. And precision is another word for consistent. Right? Repeatable is another word. Reliable. Okay? So if these numbers are all close to each other, which they are, they're off by 1 or 2. So they're very close to each other, and that means that they're precise. So the precision is how close each number is to each other. Okay? And that just means that the instrument's reliable. So if you measure temperature, you're taking your temperature of somebody that you think is sick in your household, and you record their temperature, you want a thermometer that is consistent. You want to be able to record the temperature and get something kind of close every time. You don't want to use a thermometer, get 98.7 one time, and then the next time you get 102, and then you measure it again, you get 98 again. Like, you want it to be precise. You also want it to be accurate. You want it to give you a real temperature. You don't want it to be off. All right, and I've got one that we use. That's actually kind of low. So every time I take my temperature and I'm not running a fever, I end up getting like 96, 97. And I'm like, well, if my temperature was actually that, I probably would be dead. So I know that it's not accurate or precise because it's off. And that's just because it's a cheap thermometer. All right, so let's look back at our pictures and see who was precise. All right, John threw them all over the place. They're not together. And so if you didn't throw them together in the same place, then it's not precise. So let's write not precise. Now this one is precise. Look, they're all in the same area. So that is precise. And this one also, they're all together precise. So when you play darts again next time, and a buddy's asking you, well, how do you play darts? How do you get so good? Tell them that you need to be precise and accurate. Yeah. All right. They can be accurate, precise, both, or neither. So this one, let's go over it again. This one is accurate because it's on bullseye and precise. So accurate and precise because they're all together. This one is, we did that. This one is precise because they're all in the same spot, but he was off. His technique was wrong. And then we call that systematic error. So he was throwing a little high or something. He was overcompensating, and so he ended up throwing them kind of high. But he threw them all in the same spot. So that's precise but not accurate. And then this guy, John, not precise nor accurate. Did not hit bullseye, nor are his darts together. Okay. All right, so here's an example. Data that students obtained during an experiment are shown below. The actual mass of an object is 10. So somebody smarter than us measured the mass of this object and got 10. And we know it's supposed to be 10. Okay. Now we measure it with our balance, our cheap balance, and we get 5.5, 5.6, 5.56, 5.54, and 5.56. All right, and so you should be able to see that these numbers are very close to each other, which means that our balance is precise. It is capable of reproducing results, getting something 5.5 something, right? There's a little bit of variability, but not much. And there's another way to tell how different these numbers are from each other. Do y'all know what that one's called? Standard deviation. So if you're in math, standard deviation tells you how different they are from each other. You can get a plus or minus. Let's see, our standard deviation here is 0.6 to 0.0, so plus or minus 0.6. That's our standard deviation. So they go up or down from 0.6. So this would be precise because they are close to each other, but it is not accurate. Why is it not accurate? Well, we were supposed to get 10, and we got half of that. which is exactly about 50% error. That's not accurate. For percent error, you want like 90% error or 10% error. Less than 10% error is acceptable. Okay. All right. Last one. Determine the percent error for data in the previous question. Oh, I didn't realize I did this one, so we'll do this one together. I thought this was a different question. So percent error is the measured minus the true divided by the true times 100. All right, our measured value is the average from these guys. Okay, so let's get my calculator. 5.5 plus 5.56 plus 5.54 plus 5.56. I add all those up and I get my average. So I add them all up and then I divide by the number of values. There's 1, 2, 3, 4 values, so I divide by 4. All right, so my average is 5.54. Okay, remember average is equal to the sum of the values divided by the number of values present. All right, if you've got a grade for the semester in chemistry, you take 4 tests in a semester of chemistry, your test average is going to be the sum of those 4 grades. Let's say you make 400s. So you're going to do 100 plus 100 plus 100 plus 100. That's 400. And then you divide by 4. And that'll give you your average for the test grade category for your grade. Okay, so we're going to take the sum of the values divided by the number of values. So we get 5.54, and we're supposed to get 10 grams. Oh, gosh. So we're going to divide that by 10.0, and then we're going to divide by 10.0. And then multiply what we get out of all of that by 100. So let's do 5.54 minus 10 equals negative 4.46. Divide by 10, negative 0.446, and then I'm going to times by 100. And I get negative 44.6%. It can be negative. So my percent error is negative 44%. So that means that we were too low. Obviously, we were too low. We had 5 instead of 10. So 44.6% error is a lot of error. So we were not accurate, and we were off by 44%. So we could have done better. All right, thank you guys. Hope this helps. Let me know if you have any questions in the chat.